Hello everyone, so it's my pleasure to present our work here, Temporal-aware automated reteaming for text-to-video models. And it's a collaborative work between the UESTC, University of Manchester, and Group Nanyang Technology University and the Jin University. And my name is Jiamin He. So this work has been accepted by the CVPR 2026 as a oral presentation. Okay, here is a brief introduction to our motivation of this work. So we want to bridge the temporal safety gap in the current T2V models or T2V services. And the existing reteaming methods that always target the static image or the text generations, basically they are mostly insufficient for the temporal dynamics in the text-to-video generations, because they are all focused on the unsafe semantics in the static generations. And the key insight of our work is we want to design some textually safe prompts. They can generate some temporally helpful videos in a efficient and reachable refinement loops. So as image shown here, we can find a static meta harmful prompts, some simple and direct words, some computer suicide and poison. They can easily and successfully filtered and detected by the NSFW detectors. But after the temporal-aware optimization with our frameworks here, we can find that a totally safe prompts, they can also generate a similar semantics in the temporal video generations. So we want to define a problem formally. So how to systematically uncover the temporal vulnerabilities in the current T2V models with adversarial prompts are textually safe. They can easily to bypass the NSFW text detectors, but generate unsafe videos through the temporal dynamics. And here are 4 points of our contributions. The first one is our tier temporal frameworks. It's the first one automatic reteaming frameworks to target the temporal vulnerabilities in the current T2V models. And we also construct the multi-stage optimizations on the generators with the prompt level and the temporal consistency rewards. And we also conduct a fine-grained and a comprehensive evaluations on the current and popular open source and the closed source T2V models, and compared with the 4 SOTA baselines. And we find that our frameworks are consistently higher than the best baselines. And we also expose a critical failures in the current commercial T2V API safety filters, such as the Google View and the Minimax. So it's crucial and it has a great real-world impact of our work to remind the industries of the T2V models and the generation or the API service providers. They can improve their safety filters by this work. Okay, so here is the overview of our frameworks tier. So firstly, we construct the datasets to conduct the initial training on the generators, and in the third stage, we conduct a temporal-aware optimizations with different rewards, and during the final reteaming test case generations, we adopted a cyclic optimization with a video understanding models. We adopt the Coin3 VO here to leverage some refined guidance and the case observations from the video judgment systems. So here is the objective of our work is so firstly, how can we design and construct the datasets? We all adopted a commercial LLM to generate the datasets, and they can be divided in the 3 steps. The first one is we want to decompose the a whole harmful directive sentence into different decelerated static events, and we can adopt some temporal collectives basically like some textual words, such as the first after 2 seconds, and we can merge this kind of static events with temporal connectives to obtain a complete textually safe but can induce unsafe video generations prompts. So for the generator optimizations, it has two stages. First one, we adopt a non-master A/B to conduct the initial generator training, and we formulate our reteaming test case generations as a Markov chain process, and we also design rewards in two spaces. For the first reward term is like we extract a confidence functions from a pre-trained hate speech classifiers to maintain the safety of the prompts. And another one is the embedding pattern alignments to make sure the generated prompts is well aligned with the patterns of the designed datasets, the temporal style datasets. And for the second one rewards, we want the video semantics of the generated videos is well aligned with is well aligned with meta harmful semantics, and for the inner temporal consistency reward term, we want to ensure the utility of the generated videos, and maybe like the consistency of the generated videos and the quality of the generated videos. And here is a test case refinement loops to ensure that our reteaming test cases are effective and also being judged as safe by the textual detectors. And we adopted a video understanding models. We use the currency view here to iteratively optimize the prompts. Here are some results on the open source TTV models of our framework and compare with different rating methods. And the role is different categories of the harmful categories of the TTV generations from the TTV safety benchmark. And our work is consistently higher than the baseline methods. We also conduct some experiments on the effectiveness of on the commercial APIs, such as the Google View, the Hello Minimax Hello, and Re2. We find that our methods are still effective as open source models. And we also test cross-model transferability of our generated prompts. We find that our ASR is like 760.4%. It has a great transferability between different from models to the two models. And we've also conducted evaluations on the impact of the refining rounds during our iterative refinement. We find that the ASR rises sharply in the first 3 rounds, and it keeps stable after the 5 or 6 rounds. So it's kind of efficient for our optimizations. So in this work, our tier provides a scalable reteaming tools for the current industry developers to proactively to audit their T2V models before these models are published in the public internet. So I hope our work can bring some real world impact, and I hope this can be helpful for the current T2V developers or the T2V service providers. Thanks for listening.